typically says, you know, a layman's definition is sort of like everything's going to maximum disorder. In fact, as I was in graduate school, I heard so many people say the second law of thermodynamics means evolution is impossible, and of course it wasn't, and they didn't understand it. But the second law of thermodynamics plays a very key role in the overall process that I'm talking about here. Random design really has two components: the laws of randomness, such as in the second law of thermodynamics, but also a second process called combinatorial mathematics. And we'll look at that in a little more detail before. So to conclude our session today, I'd like for us to look at a small video clip. What I've done is I've created short introductions to Random Designer for each chapter on a video clip. And this is the introduction for Chapter 3, which is about the second law of thermodynamics and how it provides as that driver and that energy source for the creation of life. Welcome once again to our discussion of Random Designer. In this chapter, we will explore a fascinating and mysterious law of nature called the second law of thermodynamics. And we'll learn how this law is linked to all of creation. Throughout history, many of the most profound scientific and medical advances were initially spurred by very simple and sometimes accidental observations. Sir Isaac Newton, a falling apple, and gravity come to mind. Alexander Fleming, a contaminated mold culture, and the discovery of penicillin serve as yet another vivid example. It was during the mid-1800s when the American scene was rapidly changing from an agricultural to industrial society that two engineers, Rudolf Clausius and Lord Kelvin, made another seemingly mundane observation. They put it this way: heat never passes from a cold body to a warmer body on its own. On the surface, such a statement certainly doesn't seem incredibly original or profound. After all, everyone knows it's a bad idea to touch your finger to a red-hot stove. But sometimes, when we look beyond the surface phenomena, we find something more. And with this new awareness, life has a way of teaching us some very important lessons. The Kelvin-Clausius observation actually turned out to be huge. Within decades, scientists realized that the principal force driving heat transfer was actually a general law of nature. They called this law the second law of thermodynamics. Today we understand it to be one of the primary governing principles of all physical and chemical properties in the world. A layman's definition of the second law might be put something like this: anything left to itself tends to become more random and disorganized. In other words, left to themselves, things tend to fall apart. And in this observation, we see that the second law of thermodynamics imparts to our world a very important characteristic: directionality. If this whole concept seems just a bit intimidating and difficult, well, then welcome to the club. There are very few scientists, even those bespectacled theoretical types, who actually wake up every morning thinking about these things, would claim to understand it fully. Nevertheless, the basic premises of the second law are fairly easy, and the ultimate consequences for life, that is, decay and death, are readily apparent to everyone. So how does the law of randomness relate to a discussion of science and faith? In this chapter, we will answer that question, first reviewing the fundamental principles of the second law and highlighting a few examples of the many destructive effects it has in our world. We will then explore in more detail one of the most amazing paradoxes of all time, showing how the raw, unbridled forces of chaos and randomness actually fuel the formation of structure, order, beauty, and ultimately even life itself. Don't be afraid of the seeming paradoxes in life. Sometimes, when we look more closely, we find a deeper reality. Just one more clue in God's larger creative plan. I want to thank all of you for coming. I don't know what we have for time. I don't have a watch. But what I will do next time is I will pick up on this concept, talk to you about what random design is, and then we'll begin to get into some of the more difficult topics
So we'll really be deep in, today was big picture, next time we'll be into details and how things play out and how random design is important for Christians in our culture. So thank you very much for coming. I really do appreciate it. Then I'd like to go and talk about a new kind of Christian and why I believe that it's important for us as Christians to be intelligent about how we address the science-faith issue. Then the next one, putting science and faith together. How can we establish a paradigm that allows us to effectively integrate our understanding of the realities of the physical world and also be able to cling to our faith and those things that really matter to us most? And then finally, a call to come home, where I simply say that the most important thing about Random Designer is in the second half of the book, where we don't talk about science very much. It's the message that Jesus gave to us, that it's all about relationships. So with that as a background, let's pick up where we left off last time, talking about actually what random design was. So this was the question where we quit. You remember the DVD that described that process? Now the second law of thermodynamics, funneling everything basically in a sea of randomness toward maximum disorder, can actually, that energy can be caught and used in a productive, positive way. So random design really encompasses two major components. The laws of randomness are creative, component number one, and the second component involves what we call combinatorial creation. Mathematicians say that random design then would use what's called brute force. Now it's kind of difficult to explain brute force to someone who's not a mathematician. Actually, I had to learn it myself as I was going through the process. But it really works out simply this way. Maybe we can describe it perhaps with a question. Presented with a problem to solve and no limitations of time and resources, which of the following approaches would most likely arrive at the best solution? A, think the problem through as best as possible and then try what seems to be the one best idea. 2, think the problem through as best as possible and then try the best 10 ideas. Or we could work our way up. Or finally, simply try all the possibilities. Combinatorial mathematics and the idea of brute force simply says we try them all. Try them all. So I hope that you'll come to the conclusion that this would probably be the best one for us to encounter here. This one offers the best hope of success, provided there's no limitations of time, provided there's no limitation of resources. So that expansive approach appears to be God's method of creation as well. In short, it's random design. Now remember, keep in mind, random design has two components. The laws of randomness are creative, serving as a driving force, and then we've got this combinatorial mathematics producing a virtually infinite number of possibilities that can be used in a creative way. There are lots of different examples of this. The one I'd like to talk about first here involves the chemical bases in DNA. I actually brought some of them. Here they are. 4 chemicals: adenine, guanine, cytosine, and thymine. Little white powders. I'll pass them around. You can look at them if you like. This is the stuff of life. Just as the Morse code, a series of dots and dashes in different sequences, can code for letters of the alphabet, and from these letters we can create words, and from words we can create sentences and paragraphs and books, and we can have a whole sense of communication with one another. In the same way, these 4 chemical bases, just 4, are ultimately responsible for writing the code that prescribes all life on the planet. So basically the difference between a herpes virus, a honeybee, a horse, or a human ultimately works its way back